Artificial intelligence, or AI, has become a buzzword in today's digital era. But what exactly is it? Essentially, artificial intelligence is the simulation of human intelligence processes by machines, especially computer systems. It's a multidisciplinary field that encompasses computer science, psychology, linguistics, philosophy, and many others. The concept of AI was first mooted back in the 1950s during a conference at Dartmouth College where the term artificial intelligence was coined. However, it wasn't until the turn of the 21st century that we began to see its potential, with advancements in technology and data availability. Since then, AI has been rapidly integrating itself into various sectors of our lives, transforming the way we live, work, and play. It's now an integral part of many industries, including healthcare, finance, entertainment, and transportation. In healthcare, AI is being used to predict diseases, personalize treatments, and even assist in surgeries. In finance, it's streamlining processes, detecting fraudulent activities, and improving customer experience. The entertainment industry is leveraging AI for content recommendations, special effects, and even script writing. And in transportation, AI is the driving force behind self-driving cars, intelligent traffic management systems, and optimized logistics. But why is AI so important? Well, it's because of its ability to learn, reason, and self-correct. It can process vast amounts of data, identify patterns, and make decisions, often more quickly and accurately than humans can. This makes it an invaluable tool for solving complex problems and making our lives easier. As we move forward, it's crucial to understand that AI isn't just one thing. There are different types of AI, each with its unique capabilities and applications. These include narrow AI, which is designed to perform a specific task like voice recognition; general AI, which can understand, learn, and apply knowledge across a wide range of tasks; and machine learning, a subset of AI that enables machines to learn from data and improve their performance over time. So, as we delve deeper into this fascinating world of AI, remember that its potential is as vast and varied as the intelligence it aims to replicate. The AI that most of us interact with on a daily basis is known as narrow AI. This type of AI is designed to perform a specific task, and it does so with remarkable efficiency, making it a vital part of our everyday lives. You may not even realize it, but you're likely using narrow AI multiple times a day. Let's talk about Siri, Apple's virtual assistant, or Alexa, Amazon's cloud-based voice service. These AI-powered assistants help us set reminders, answer trivia questions, play music on our command, and even control our smart homes. They're capable of these functions because they've been specifically designed for them. That's the essence of narrow AI. It's brilliant at the tasks it's been programmed to do. Then there's the recommendation system employed by platforms like Netflix or Spotify. Ever wondered how Netflix seems to know your taste in movies, or how Spotify creates a playlist that feels hand-picked? That's narrow AI at work. These systems analyze your past behavior, compare it to millions of other users, and then suggest what you might like. But here's the catch. While narrow AI might seem intelligent, it operates under a very limited, predefined range. Siri may be able to tell you the weather forecast or schedule an appointment, but ask it to write a poem or make a cup of coffee, and you'll be met with silence. That's because these tasks are outside of its programmed capabilities. In essence, narrow AI is like a highly skilled artisan, a master in its trade, but oblivious to everything outside of it. It's not capable of understanding or learning anything beyond its programming. Despite its limitations, narrow AI has paved the way for more advanced forms of AI, one of which is general AI, but that's a topic we'll delve into in our next segment. So stay tuned. General AI, also known as AGI, takes the concept of AI to a whole new level. Now you might be thinking, how does it do that? Well, general AI is designed to understand, learn, adapt, and implement knowledge in a way that is not limited to just one task. It's like having a digital assistant that can do more than just schedule your meetings or remind you of your appointments. Imagine a software that can learn how to play chess, then use that understanding to excel at a completely different game, say poker. It's like teaching a child how to ride a bike, and then they use that balance and coordination to learn how to skate. This is the beauty. of general AI. It's the ability to transfer learning from one domain to another. Unlike narrow AI, which is designed to perform a specific task, such as voice recognition or image classification, general AI can theoretically accomplish any intellectual task that a human being can. It's like having a universal tool, a Swiss Army knife of artificial intelligence. But here's the catch. While it sounds incredibly promising, general AI is largely theoretical at this point. It's a concept, a goal that many researchers and scientists are striving to achieve. The technology is not there yet, and there are significant challenges to overcome. General AI requires an enormous amount of data, computing power, and advanced algorithms, not to mention the ethical considerations and potential risks associated with an AI that can outperform humans in most economically valuable work. Nonetheless, the pursuit of general AI is an exciting journey. It's like exploring uncharted territories, pushing the boundaries of what's possible. The research being conducted today could revolutionize our world in ways we can't even imagine. So, while we wait for the realization of general AI, let's not forget about another type of AI that's already making waves in the tech world. Machine learning is a powerful tool that's helping us solve complex problems and make sense of the world. But that's a story for another time. Even as we await the realization of general AI, another type of AI, machine learning, is already making waves in the tech world. Machine learning, or ML, is a subset of AI that's all about learning and improving from experience. Now, what does that mean in a practical sense? Let's break it down. Unlike traditional programming, where a developer writes specific instructions for a computer to follow, machine learning flips the script. It allows computers to learn and make decisions without being explicitly programmed to do so. It achieves this through algorithms, a set of computational procedures that can learn information directly from data. And the beauty of it all is that these algorithms don't rely on a predetermined equation as a model. Instead, they dynamically adapt their understanding as they process more and more data. Much like how we humans learn from our experiences, these algorithms refine their knowledge over time, making them incredibly versatile and powerful. So how is this used in the real world? Well, machine learning is everywhere. From spam filters in your email inbox that learn to identify junk mail, to search engines that refine results based on your browsing habits, to credit score prediction systems that analyze a multitude of factors to assess your creditworthiness. Take the spam filter example. When you mark an email as spam, the algorithm takes note. Over time, it learns to identify similar emails as spam, thereby improving its accuracy. It's like training a puppy. With enough repetition, it eventually gets it. Or consider credit score predictions. These algorithms analyze a wide range of factors: your payment history, credit utilization, length of credit history, and more. By learning from this data, they can make incredibly accurate predictions about your likelihood to repay a loan. In short, machine learning takes the vast amounts of data we produce, learns from it, and uses it to make our lives easier and more efficient. It's a crucial component of AI, empowering systems to adapt and improve over time. Machine learning, with its ability to learn and adapt, is a powerful tool in the AI arsenal. From Siri helping us schedule appointments, to Netflix recommending what to watch next, AI is revolutionizing our lives. We've journeyed through the exciting world of artificial intelligence, delving into its core concepts and types. Let's take a moment to recap. Artificial intelligence, in essence, is the simulation of human intelligence processes by machines, particularly computer systems. It's a broad term that encapsulates a variety of subsets, including narrow AI, general AI, and machine learning. Narrow AI, also referred to as weak AI, is designed to perform a narrow task, like voice recognition. It's this type of AI that powers the voice assistants we interact with daily, from Siri and Alexa to Google Assistant. They can answer our questions, play our favorite songs, and even control our smart homes, all thanks to the power of narrow AI. On the other hand, general AI, often called strong AI, possesses the ability to understand, learn, adapt, and implement knowledge across a wide range of tasks. It's the kind of AI we often see in science fiction, where machines can fully replicate human intelligence. However, it's important to note that this type of AI is still largely theoretical and remains a topic of active research. Lastly, we have machine learning, a subset of AI that provides systems the ability to learn and improve from experience without being explicitly programmed. It's the engine that powers recommendation algorithms on platforms like Netflix and Amazon, making our digital experiences more personalized and enjoyable. The potential applications of these types of AI are vast, spanning across industries from healthcare to finance and even entertainment. It's a thrilling time to delve deeper into this technology and explore its potential impacts. As AI continues to evolve, we can only anticipate how it will further transform our future. Don't forget to subscribe and like the video for more intriguing insights into the world of technology.
Have you ever wondered how robots can perform complex tasks that were once only possible for humans? Enter the fascinating world of artificial intelligence, or AI, and robotics. These two fields, when integrated, create a dynamic duo that's transforming our world. Think of it this way: AI is the brain, the powerhouse of decision-making, while robotics is the body, executing those decisions in the physical world. This integration has sparked an exponential growth, propelling us into an era where machines can learn, adapt, and perform tasks with an efficiency that rivals and, in some cases, surpasses human capabilities. From the assembly line in factories to the fields of agriculture, from healthcare services to domestic chores, AI-powered robots are making their mark. The potential for what can be achieved in this field is vast, and we are only scratching the surface of what's possible. To truly understand its impact, let's delve into some real-world applications of AI-powered robots. Imagine a factory where robots and humans work side by side, increasing productivity and reducing errors. That's not a scene from some futuristic movie. It's a reality in the world of manufacturing today. Artificial intelligence, or AI, is transforming the way factories operate. Take the case of a leading automobile company that has successfully incorporated AI robots into its assembly lines. These robots aren't just mindlessly repeating tasks, they are learning, adapting, and improving with every move they make. They're equipped with sensors and machine learning algorithms that allow them to understand and respond to their environment. For instance, if a part isn't fitting correctly, the robot won't just keep trying the same ineffective method. It will adapt, learning from the experience, and find a new approach to get the job done. This ability to learn and adapt is revolutionizing manufacturing. It's reducing errors, increasing efficiency, and freeing up human workers for more complex tasks. And it's not just about efficiency. AI robots are also improving safety in factories. They can be programmed to perform tasks that are dangerous for humans, reducing the risk of workplace accidents. In short, AI robots are helping the manufacturing industry to be more productive, more efficient, and safer. It's a win-win situation for everyone involved. And this is just the beginning. AI robots are making their way into other industries as well. What if we could reduce the manual labor in farming and increase crop yield at the same time? Well, the answer is already here, in the form of AI robots assisting us in the fields. Imagine a farm where robots are the new workforce, tirelessly performing tasks from dawn till dusk. Take a case study of a modern farm that's embraced this technology. Here, AI robots are revolutionizing the way we farm. They're designed to handle tasks that were traditionally labor-intensive and time-consuming. From sowing seeds in the spring to harvesting crops in the fall, these robots are there every step of the way. These AI robots are not just tireless workers, they're also precision experts, planting seeds at the optimal depth and distance, watering crops with just the right amount of water, and harvesting with a level of precision that minimizes waste. This accuracy is a game changer, reducing resource usage and increasing crop yield, making farming more efficient and sustainable. Moreover, These robots come equipped with advanced sensors and cameras that monitor crop health, detect pests and diseases early, and even predict weather changes. This allows for proactive measures, ensuring higher quality produce and less crop loss. In essence, AI robots are not just transforming agriculture, they're making it more productive, more sustainable, and more resilient to changes. But the reach of AI robots extends beyond the farm. They're also making a big difference in healthcare. Could robots possibly be the future of healthcare, providing critical assistance to doctors and patients alike? Picture a bustling hospital in the heart of the city. Amid the flurry of white coats and scrub-clad professionals, a new kind of healthcare worker is making its mark. These aren't your typical doctors or nurses, but AI robots designed to assist in a multitude of tasks, from patient monitoring to medication dispensing and even surgery. Let's take a closer look at this cutting-edge technology. AI robots are equipped with sophisticated sensors and algorithms, enabling them to monitor a patient's vital signs, detect irregularities, and alert the medical staff promptly. This not only frees up time for healthcare professionals, but also ensures round-the-clock care for patients. But that's not all. AI robots are also making strides in the realm of medication dispensing. By taking over this repetitive task, they minimize human error, ensuring that patients receive the correct medication at the right time. This not only boosts patient safety, but also increases the efficiency of the healthcare system. Now let's venture into the operating room. Here, surgical robots, guided by AI, are transforming the field of surgery. With their precision and consistency, they can perform intricate procedures, improving patient outcomes and reducing recovery times. As we can see, the possibilities with AI robots are seemingly endless. As we delve into the world of AI and robotics, it's clear that this technology is revolutionizing various sectors. The impact is transformative, to say the least, and the advancements we've seen so far are only the tip of the iceberg. In manufacturing, AI robots have brought about a new era of precision, efficiency, and safety. They've taken on repetitive, heavy-duty tasks, freeing up human workers for more complex and creative roles. The result is a symbiosis of human intellect and machine strength, pushing the boundaries of what's possible in production lines. Agriculture, too, has been transformed. AI-powered robots are performing tasks from soil analysis to crop harvesting, working tirelessly to feed a growing global population. They're enabling smarter, more sustainable farming practices and helping us meet the challenges of climate change and food security head-on. And let's not forget healthcare, where AI robots are becoming integral parts of our medical teams. From assisting in complex surgeries to providing round-the-clock patient care, these robots are improving outcomes and revolutionizing patient care. The intersection of AI and robotics is a fascinating space, a convergence of science, technology, and imagination. The robots of today are not just tools, but partners, collaborators, and even caregivers. They're helping us solve some of our biggest challenges and opening up a world of possibilities. The future of AI and robotics is indeed promising, and it's exciting to imagine where this technology will take us next.
Ever pondered how computers can recognize images? That's the magic of computer vision, a field of artificial intelligence that enables computers to interpret and understand the visual world. It's not just about recognizing an image, it's about understanding its context, identifying objects, and even predicting actions. In this digital age, computer vision is a pivotal technology. It's the backbone of facial recognition systems, self-driving cars, and even your smartphone camera's ability to detect a face for that perfect portrait shot. But it doesn't stop there. Imagine a world where computers can diagnose diseases by analyzing medical images, or a surveillance system that can identify potential threats automatically. That's the potential of computer vision, a bridge between the digital and the visual world, making our interactions with technology more intuitive, efficient, and human-like. So, how exactly do computers recognize images? Let's delve into this fascinating world. The first step in image recognition is something called image classification. Now, what does this fancy term mean? Well, imagine you're flipping through a photo album. You can easily identify the pictures, right? There's a picture of a dog, a car, a beautiful sunset. Your brain effortlessly classifies these images into categories. This is exactly what image classification aims to achieve, but for computers. Image classification is a method used in computer vision that allows machines to categorize images into predefined classes. It's like teaching a computer to look at a picture and say, "Hey, that's a cat," or "Look, that's a bicycle." It's a fundamental step in image recognition and a crucial component of many innovative technologies, from social media filters to self-driving cars. But how does it work? In essence, the computer is trained using a vast database of labeled images. These images serve as a guide, teaching the machine to recognize patterns and features. For instance, a car might be recognized by its shape, wheels, or headlights. An apple might be identified by its round shape and red color. Over time, the computer learns to associate these features with their corresponding labels, and can then identify these objects in new, unseen images. Despite its seemingly simple task, image classification is a complex process that involves advanced machine learning and artificial intelligence algorithms. It's an essential building block in the world of computer vision, enabling machines to make sense of the visual world around them. In a world inundated with images, from the millions we capture on our smartphones to the countless security cameras monitoring public spaces, image classification plays a crucial role. It allows machines to recognize everyday objects, animals, and even people, transforming a sea of pixels into meaningful information. With image classification, computers can identify what an image is. But can they pinpoint where exactly an object is located? That's where object detection comes in. Object detection takes image classification a notch higher. Imagine a scenario where you're not just interested in knowing if there's a cat in the image, but you also want to know where the cat is. That's the essence of object detection. Object detection, in simple terms, is a process that combines image classification and location identification. It doesn't just tell us what's in an image, but also where it is. So it's like saying, "Hey, there's a cat in this picture, and it's right there at the bottom left corner." This combination of what and where is what distinguishes object detection from image classification. But how does it work? Well, it starts by dividing the image into a grid of cells. Each cell is then passed through a classifier to detect if an object exists in that cell. If an object is found, it's then classified into categories like cat, dog, car, and so on. Also, the location of that object within the cell is determined. This process is repeated across all cells, and that's how we end up with a map of where each object is located in the image. Now let's talk about some real-world applications of object detection. You've probably heard about autonomous driving cars. These vehicles rely heavily on object detection to navigate through the streets. They need to identify and locate pedestrians, other vehicles, street signs, and more. Without object detection, autonomous driving would simply not be possible. Another application is in the field of surveillance. Security cameras equipped with object detection can identify and track people, vehicles, or any suspicious activity. This can greatly enhance the efficiency and effectiveness of security systems. In a nutshell, object detection is a powerful tool that allows machines to perceive the world more like we do. It's not just about recognizing objects, but understanding their context within a scene. Object detection enables computers to locate objects in an image. But what if we need more detailed information? That's where image segmentation shines. Image segmentation is all about getting into the nitty-gritty details. It's the process of slicing and dicing an image into multiple segments, akin to a jigsaw puzzle. Each piece or segment represents a specific object or part of that object. Think of it like this. You're looking at a scenic photograph of a park. Image segmentation doesn't just tell you that there's a park in the photo. It goes beyond and breaks down the image into different segments: trees, benches, the walking path, and even the little squirrels scampering across the grass. It's a deep dive into the details, separating each component and giving it its own identity. But how does image segmentation work? It's all about pixels. The algorithm groups together pixels that share similar characteristics. These could be color, intensity, or texture. Each group of similar pixels forms a segment, representing a specific object or part of an object. Now, why is image segmentation important? Well, it has significant applications in various fields. For example, in healthcare, it's used to identify diseases. A doctor can use image segmentation to analyze a medical image like an MRI. and separate healthy tissue from diseased tissue. This helps in accurate diagnosis and treatment planning. So you see, image segmentation is the most complex and detailed form of image analysis. But all these concepts together make image recognition possible. So, we've journeyed through the fascinating world of image recognition. We've delved into image classification, getting a feel for how computers are trained to categorize visuals. We've explored object detection, understanding how machines can identify and locate items within an image. And we've unraveled the complexities of image segmentation, revealing how computers can break down a picture into multiple segments for deeper analysis. Next time you see a computer recognizing images, you'll know there's a lot more than meets the eye. Until then, stay curious and keep exploring.
Have you ever wondered how artificial intelligence is reshaping the landscape of healthcare? This question isn't just for the tech-savvy or the medical professionals among us. It's a question that's becoming increasingly relevant to each and every one of us. You see, the world of healthcare is evolving at a rapid pace, fueled by advancements in technology, and at the heart of this evolution is artificial intelligence, or AI. AI's role in healthcare is expanding, with an increasing interest from both the scientific community and the public. It's promising to revolutionize how we diagnose diseases, how we interpret medical images, and even how we personalize medicine to the individual patient. But like any transformative technology, it's not without its challenges. Questions about data privacy, accuracy, and implementation are hot topics in this ongoing conversation. Indeed, AI is not just a concept of the future, it's here, and it's transforming healthcare as we know it. One of the most prominent applications of AI in healthcare is in the field of medical imaging. Imagine a world where the process of diagnosing diseases is faster, more efficient, and incredibly accurate. This is not a glimpse into a distant future, but the reality we're living in today, thanks to the integration of artificial intelligence in medical imaging. Artificial intelligence, or AI for short, has been revolutionizing the way we analyze medical imaging, such as X-rays, kinetic scans, and MRIs. By leveraging the power of machine learning and deep learning algorithms, AI has the ability to sift through thousands of images in a fraction of the time it would take a human. But it's not just about speed. AI can highlight details that might be missed by the human eye, making it a valuable tool in detecting early signs of diseases. Let's take a look at a practical example. Google's DeepMind AI. This advanced piece of technology has been trained to spot eye diseases in scans as accurately as doctors. It can analyze a 3D scan of a patient's eye and make a diagnosis in mere seconds. This is a game changer in the field of ophthalmology, where early detection can mean the difference between vision preservation and vision loss. DeepMind AI is not only matching the diagnostic accuracy of healthcare professionals, but it's also freeing up their valuable time. This allows them to focus more on patient care and less on the time-consuming task of image analysis. But like any technology, AI is not without its challenges. It requires vast amounts of data for training, and there are privacy and security considerations to take into account. However, the potential benefits of AI in medical imaging far outweigh these challenges. The integration of AI in medical imaging is not about replacing healthcare professionals, but rather augmenting their capabilities and enabling them to provide better patient care. It's about harnessing the power of technology to improve health outcomes and transform lives. With the help of AI, healthcare professionals can now make faster and more accurate diagnoses, improving patient outcomes. Another exciting area where AI is making a difference is in disease diagnosis. Artificial intelligence, through its ability to analyze massive amounts of data, is revolutionizing how we detect and diagnose diseases. And it's not just about speed, but accuracy as well. This technology is particularly beneficial in the early detection of diseases like cancer, heart disease, and neurological disorders. Take cancer diagnosis, for instance. It's a known fact that early detection can significantly increase the chances of successful treatment. AI systems, with their advanced pattern recognition abilities, can sift through thousands of medical images and identify abnormalities that might be missed by the human eye. This can lead to quicker diagnoses and faster initiation of treatment. Now let's delve into a case study of AI in disease diagnosis. Consider IBM's Watson, a high-profile example of AI in healthcare. Watson uses AI to analyze a patient's medical history, genetic data, and relevant scientific literature to suggest a diagnosis and potential treatment paths. This is a complex task, considering the vast amount of data Watson has to process. Yet, it can do this in a fraction of the time it would take a team of medical professionals. Watson's capabilities were put to the test in a study involving a rare form of leukemia. The AI was able to correctly diagnose the condition in a patient who had been misdiagnosed initially. The accurate diagnosis by Watson led to a change in the patient's treatment plan, which subsequently improved the patient's health. This is just one instance of how AI can potentially save lives by enabling timely and accurate disease diagnosis. It's a testament to the power of AI in healthcare and a glimpse into what the future holds. AI in disease diagnosis is not without its challenges, though. Concerns about data privacy, the need for extensive training of AI systems, and the requirement of large, diverse datasets for AI to be effective are some of the hurdles that need to be addressed. Yet the potential benefits are immense. This shows how AI can potentially save lives by enabling timely and accurate disease diagnosis. AI is also playing a pivotal role in the development of personalized medicine. Imagine a world where your doctor could prescribe a treatment tailored specifically to your genetic makeup and lifestyle. That's exactly what AI is making possible in the field of personalized medicine. Consider Tempus, a technology company that's making waves in the healthcare industry by using AI to personalize cancer treatment. The company has developed a platform that uses AI to analyze vast amounts of clinical and molecular data, including data from a patient's own genetic code. By understanding the unique genetic mutations that cause a patient's cancer, Tempus can suggest the most effective treatment strategies. But it's not just about the genes. AI can also take into account lifestyle factors that can influence the course of disease. For example, diet, exercise, sleep patterns, and even stress levels can all play a role in how a patient responds to treatment. By considering all these factors, AI can help doctors create a treatment plan that's not only personalized, but also holistic. This is a game changer for healthcare. Personalized treatments have the potential to be more effective and have fewer side effects than one-size-fits-all approaches. And it's all thanks to AI's ability to analyze complex data and make precise predictions. As you can see, AI is paving the way for a more personalized approach to healthcare. The examples we've explored are just the tip of the iceberg. The potential of AI in healthcare is immense, from enhancing medical imaging to improving disease diagnosis and personalizing medicine for individual patient needs. However, challenges persist, including ethical considerations and data security. Yet with continued research and development, solutions to these challenges are within our grasp. As we continue to explore and develop AI technologies, the question is not if, but how these tools will continue to revolutionize healthcare in the years to come.
Have you ever pondered about how far artificial intelligence might go? Could robots actually replace humans one day? These are questions that might sound like they're straight out of a science fiction novel, yet they are becoming increasingly relevant in today's fast-paced world of technology. Artificial intelligence, or AI, is no longer a distant dream. It's here, evolving, learning, and growing every day. This invisible force is quietly weaving itself into the fabric of our lives, from our smartphones to our cars, from our workplaces to our homes. But where is it heading? What does the future hold for AI? As we stand on the brink of what could be a significant shift in our society, it's important to understand the potential implications of this technological revolution. As we delve into the world of AI, think about the implications it might have on our lives and society as a whole. To understand the future, we must first look at the present. So, what's the current state of AI? Artificial intelligence, or AI as we often call it, is no longer a concept of the future. It's here, now, and it's shaping our lives in ways we might not even realize. The present state of AI is marked by several key trends that are molding the way we experience technology and the world around us. One of the most significant trends is machine learning. It's an application of AI that allows systems to learn and improve from experience automatically without being explicitly programmed. From recommendation algorithms on streaming platforms to predictive text on our smartphones, machine learning is already a part of our daily lives. Then comes natural language processing. It's the technology behind our digital assistants like Siri and Alexa that understand and respond to our voice commands. It's also powering sophisticated chatbots that provide customer service, answer queries, and even offer mental health support. A major breakthrough in the current state of AI is the development of autonomous vehicles. Powered by AI, these self-driving cars are expected to revolutionize transportation, making it safer and more efficient. They're already being tested on roads and are expected to become commonplace in the not-so-distant future. AI also has notable applications across various industries. In healthcare, AI systems can analyze medical images, predict patient outcomes, and even assist in surgeries. In finance, they're used for fraud detection, risk management, and personalized banking services. In education, AI is transforming the way we learn through personalized learning experiences and virtual tutors. These advancements aren't just technological marvels, they're tools that are making our lives easier, safer, and more efficient. But while we marvel at these achievements, it's crucial to remember that we're still in the early stages of the AI revolution. These advancements in AI are just the tip of the iceberg. The real revolution is yet to come. The rise of AI brings with it both excitement and fear. One area of concern is the job market. Will AI take away jobs or create new ones? AI, much like any technological advancement, has the potential to disrupt traditional job markets. It's a double-edged sword. On one side, there's the fear that automation and AI could replace human labor, leading to job losses. In fact, some studies suggest that up to 40% of jobs could be automated in the next 2 decades. Sectors like manufacturing, logistics, and even customer service are already feeling the effects. But let's flip the coin. On the other side, we see AI creating new jobs. These are roles that didn't exist a decade ago. AI specialists, data scientists, machine learning engineers, these are some of the most sought-after positions today. And it's not just about the tech industry. We're seeing the rise of AI ethics officers, AI trainers who teach AI systems to understand human behavior, and AI maintenance workers who keep these systems running smoothly. Moreover, AI can augment human capabilities, making us more efficient and productive. It's not necessarily about replacing us, but empowering us. For instance, AI can help doctors diagnose diseases more accurately or assist architects in designing more sustainable buildings. However, this transition won't be seamless. It's crucial to understand that new jobs created by AI might require skills that the current workforce doesn't possess. This calls for significant upskilling and reskilling efforts. Governments, businesses, and educational institutions need to prepare for this shift, ensuring that workers are equipped to thrive in an AI-driven job market. So is AI a job killer or creator? The answer is, it's both. But remember, every technological revolution in history, from the Industrial Revolution to the digital age, has led to job displacement, but also paved the way for new opportunities. The future of work with AI is uncertain, but one thing is clear. It's going to change the way we work, for better or worse. As we look to the future, what are some of the emerging technologies in the field of AI? First, let's delve into quantum computing. This technology leverages quantum physics to solve complex problems at speeds that are unimaginable with traditional computers. In the world of AI, quantum computing could potentially revolutionize machine learning, allowing AI to learn and adapt at a much faster rate. And then there's AI ethics, a branch of research that's gaining prominence as AI continues to permeate every facet of our lives. AI ethics deals with the moral implications of AI, such as the potential for bias in AI algorithms and the privacy concerns surrounding AI data collection. It's a fascinating field that is becoming increasingly important as we continue to grapple with the societal impacts of AI. Finally, let's consider AI in healthcare. AI is being used to predict health outcomes, assist in diagnoses, and even in the development of new drugs. This technology has the potential to greatly improve patient care and revolutionize the healthcare industry. But as with any technology, these advancements come with their own set of challenges. It's crucial to navigate these waters with care, ensuring that as we push the boundaries of AI, we do so responsibly. These emerging technologies could potentially redefine our understanding and application of AI. So, is the future of AI a sci-fi dream or reality? The answer might be somewhere in between. We've explored the current landscape of AI, its potential effects on the job market, and even peeked into the promising horizons of emerging technologies. It's clear that AI is becoming a significant part of our lives, and its influence will only grow. Remember to subscribe and like AI Newsflash for more insights into the world of AI. Until next time, keep pondering about the future of AI.
Have you ever wondered if machines can be ethical, or is it just the prerogative of human beings? As we delve into the world of artificial intelligence, or AI, this question becomes more than a philosophical musing. It's an urgent query that demands our attention. AI is advancing at an unprecedented pace, transcending the boundary of being mere tools. These systems are now decision-making entities with the potential to impact lives profoundly. They're in our homes, our workplaces, even in our pockets. They recommend what we should buy, suggest who we should connect with, and even diagnose our health conditions. Yet, as we embrace these intelligent systems, we must ask ourselves, are they ethical? Are they fair? These questions are no longer the realm of science fiction. They are the new frontier we must navigate as we shape a world intertwined with AI. As we move forward, it's crucial to address these ethical issues to ensure that AI serves humanity in a fair and beneficial manner. Consider the case of facial recognition systems, where biases have been a significant concern. Facial recognition, a fascinating product of artificial intelligence, has been making waves across various sectors, from security to social media. However, beneath the surface of this technological marvel lurks the specter of bias. Take the example of commercial facial recognition systems, where studies have revealed a disturbing trend. Some of these systems have been found to be more accurate when identifying people with lighter skin tones and less accurate when identifying people with darker skin tones. This racial bias in AI systems is, unfortunately, not an isolated incident. Gender bias is another area where these systems have fallen short. In particular, they've been found to misidentify women far more often than men. This disparity is even more pronounced among women of color. These biases don't just stem from nowhere. They are often a reflection of the data used to train these AI systems. If the data is skewed, the AI will be too. For instance, if an AI system is trained predominantly on images of light-skinned men, it will inevitably be better at identifying light-skinned men. Such biases can lead to a myriad of unfair outcomes. In a law enforcement context, misidentification could result in innocent people being implicated in crimes they didn't commit. In a job application scenario, a biased AI could unfairly screen out qualified candidates based on their race or gender. Moreover, the potential misuse of these systems is a significant concern. They could be exploited to perpetuate and amplify existing societal biases, leading to further marginalization of already disadvantaged groups. In the face of these issues, it becomes clear that developing AI is not just about advancing technology. It's also about ensuring that these advancements don't come at the cost of fairness and equality. The story of facial recognition systems serves as a stark reminder of the biases that can infiltrate AI systems and the potential consequences of these biases. It underscores the importance of transparency in AI development and the need for diverse, representative datasets. This case highlights the need for fairness and transparency in AI systems, ensuring they don't perpetuate existing societal biases. Imagine you're in a self-driving car that's facing an unavoidable accident. How should the car decide what to do? This scenario isn't as far-fetched as it seems. The rise of autonomous vehicles has brought with it a slew of ethical dilemmas that we're still grappling with. Let's delve into this further. Imagine you're in an autonomous vehicle speeding down a highway when suddenly, A group of pedestrians steps onto the road. The car has two options: swerve to avoid the pedestrians, potentially causing harm to you, the passenger, or continue on its course, endangering the lives of the pedestrians. How should the car decide what to do? This is known as the trolley problem, a classic ethical conundrum, now reimagined for the age of AI. This scenario raises a multitude of questions. Who is responsible in such a situation? Is it the car's AI system, the developers who coded the AI, or the passengers who chose to use an autonomous vehicle? And who decides what the correct course of action is in such scenarios? Is the car programmed to prioritize the safety of its passengers or the safety of pedestrians? The answers to these questions are not straightforward. They require a careful consideration of ethics, law, and public opinion. It's not purely a technical problem, it's a societal one. Furthermore, these scenarios expose another layer of complexity: the issue of accountability. If an autonomous vehicle makes a decision that results in harm, who is held accountable? Can we hold a machine, a non-human entity, accountable for its actions? Or does the responsibility lie with the humans behind the machine, the ones who created, programmed, and deployed it? These are not easy questions to answer, and they highlight the intricate web of ethical considerations that come with AI systems, particularly autonomous vehicles. As we continue to develop and deploy these technologies, we must be aware of and address these ethical dilemmas. This case underscores the complexity of ethical decision-making in AI, a challenge that requires careful consideration. AI is not just about coding and algorithms, it's about the choices we make, the values we prioritize, and the society we want to build. So where does this leave us in the realm of AI ethics? Let's take a moment to reflect on the key points we've covered so far. We've seen how biases can creep into AI systems, potentially leading to unjust outcomes. We've also delved into the complex world of autonomous vehicles where decision-making algorithms can face moral conundrums that would stump even the most ethical human. These are just a few of the challenges we face in AI ethics. There are others, some more nuanced, some more blatant. Privacy, for instance, is a major concern. As AI systems become more sophisticated, they're capable of collecting, analyzing, and using huge amounts of personal data. This raises questions about consent, transparency, and control over our own information. Furthermore, the rapid development and deployment of AI technologies have outpaced our ability to regulate them effectively. This lack of oversight could potentially lead to misuse or abuse of these systems. There's a pressing need for comprehensive regulation, not just at a national level, but globally. We must establish standards that ensure AI technologies are used responsibly and ethically. The bottom line is, as we continue to refine and innovate in AI, we must also ensure we're addressing these ethical challenges head-on. It's a mammoth task, but one we cannot ignore. As we continue to integrate AI into our lives, it's paramount to address these ethical challenges, ensuring that the technology we create aligns with our shared values and principles. The question remains, how can we ensure ethical considerations are at the forefront of AI development and deployment? We invite you to ponder on these issues and ignite conversations within your communities. Let's promote the notion of collective responsibility. After all, it's not just about creating intelligent machines, it's about shaping a future where fairness, transparency, and empathy are integral to these creations. Remember, the future of AI is not just about technology, it's about the kind of society we want to live in.
Imagine this. You've just walked through your front door, hands full of groceries, and you say, "Alexa, turn on the lights." In seconds, your house is illuminated. This is the power of natural language processing and speech recognition. Every day, we interact with these technologies in myriad ways. Your smartphone's autocorrect feature, that's NLP at work. The voice-activated assistant in your car, that's speech recognition technology in action. These tools help us navigate websites, answer emails, and even translate languages in real time. They're behind the chatbots that assist us with online shopping and the sentiment analysis algorithms that help companies understand their customers' feelings. It's remarkable to think that these technologies, once the stuff of science fiction, are now embedded in our daily lives, shaping the way we communicate and interact with the world around us. The convenience of these technologies in our daily lives is undeniable, but how did we get to this point? The journey of natural language processing, or NLP, and speech recognition has been a long and fascinating one, marked by continuous advancement and improvement. To fully appreciate where we are today, we need to step back in time to the 1950s, when the seeds of these technologies were first sown. In the mid-50s, We saw the initiation of NLP with the development of machine translation. It was a time of optimism, with researchers expecting that machines would be translating languages in a matter of 5 years. But the complexity of human language proved a tougher nut to crack, and progress was slower than anticipated. Meanwhile, the roots of speech recognition were also taking hold. The first speech recognition system, named Audrey, was developed by Bell Labs in the late 50s. Audrey could recognize digits spoken by a single voice. It was rudimentary, but it was a start. The late 70s and early 80s marked the advent of machine learning, which would revolutionize both NLP and speech recognition. Then came the hidden Markov model, a statistical model that became the backbone of speech recognition for the next 2 decades. The 90s saw the rise of statistical methods in NLP, moving away from rule-based models. Fast forward to the 21st century, and we're in the era of deep learning. Neural networks, with their ability to learn intricate patterns from large amounts of data, have taken NLP and speech recognition to new heights. We've seen the development of sophisticated models like Google's BERT for NLP and Deep Speech for speech recognition, capable of understanding and generating human-like text and speech. From their humble beginnings, NLP and speech recognition have evolved immensely, thanks to the progression of computational power, the availability of large datasets, and the advancement of machine learning techniques. Each step, each stumble has been a part of this fascinating journey. From rudimentary systems to today's advanced AI models, NLP and speech recognition have come a long way, but what exactly do they do? NLP and speech recognition may sound complex, but they're essentially about teaching machines to understand and interpret human language. Now let's break it down a bit. Natural language processing, or NLP for short, is a branch of artificial intelligence that deals with the interaction between computers and humans through the natural language. The ultimate objective of NLP is to read, decipher, understand, and make sense of the human language in a valuable way. It's like teaching a machine to understand and generate human language. Think about when you type a query into Google, and it knows exactly what you're asking for. That's NLP at work. Or when you're using a chatbot, and it's able to respond to your inquiries. Again, that's NLP. It's all about understanding the context, the sentiment, the intent behind our words, and responding in a way that makes sense. On the other hand, we have speech recognition. This is the technology that enables machines to convert spoken language into written text. It's a technology that's been around for a while, but it's only in recent years that it's become really good. I mean, it's not perfect, but it's pretty impressive. Think about when you're using your phone's voice assistant and you tell it to send a text message. You speak, it writes. That's speech recognition. Or when you're in a meeting and you use a transcription service to convert the entire conversation into text. Again, that's speech recognition. So, in a nutshell, NLP is about understanding and generating human language, while speech recognition is about converting spoken language into written text. They're two sides of the same coin working together to make our interactions with machines more natural, more human-like. It's a fascinating field that's evolving rapidly. And the best part, we're only scratching the surface of what's possible. As we continue to refine these technologies, who knows what the future holds? Now that we understand what these technologies do, let's take a look at some real-life examples. From voice assistants to customer service chatbots, NLP and speech recognition are everywhere. Let's delve into some real-world applications and see how these technologies are revolutionizing various sectors. First off, tech giants like Amazon, Google, and Apple have leveraged these technologies to create voice assistants. Alexa, Google Assistant, and Siri, they're all products of advanced NLP and speech recognition. They understand human language, process our commands, and deliver responses that seem almost human-like. From setting alarms to providing weather updates, these voice assistants have made interacting with technology a breeze. Next, let's look at healthcare. NLP and speech recognition are aiding in the transformation of this vital sector. For instance, voice recognition technology is making it easier for doctors to document patient interactions. Instead of manually typing or writing notes, doctors can now dictate their notes, saving precious time and improving efficiency. Moreover, NLP is being used to extract meaningful information from these notes, enabling better patient care. In the customer service realm, chatbots are the new front line. They utilize NLP to understand customer queries and provide instant responses. This not only ensures 24/7 customer support, but also significantly reduces the workload of human agents. Moreover, sentiment analysis, another application of NLP, helps companies understand their customers' emotions and sentiments, thereby improving the quality of their service. The education sector is not left out either. Language learning apps are harnessing the power of NLP and speech recognition to provide personalized learning experiences. They can assess a learner's proficiency, provide feedback on pronunciation, and even suggest areas of improvement. Finally, in the world of entertainment, these technologies are being used to create more immersive experiences. Think about your last Netflix binge. Did you use voice search to find a show? That's speech recognition in action. As we can see, NLP and speech recognition have a wide range of applications, transforming the way we interact with machines. From improving efficiency in healthcare to enriching our entertainment experiences, these technologies are truly changing the game. So, we've seen how NLP and speech recognition have evolved over the years and the impact they have on our lives. From the dawn of these technologies, we've journeyed through their evolution, understanding their mechanisms and witnessing them in action. We've explored their diverse applications, from chatbots to sentiment analysis, and the way they've revolutionized communication. As technology advances, the potential of NLP and speech recognition continues to grow, promising an even more integrated and intuitive interaction between humans and machines. The future of communication is here, and it's powered by AI.
Ever pondered how your email filters spam on its own, or how Google knows exactly what you're searching for? The answer lies in machine learning. Pause for a beat. Machine learning, a subset of artificial intelligence, is indeed a fascinating concept. It's all about designing and implementing algorithms that enable machines to learn from data and make predictions or decisions without being explicitly programmed. Imagine teaching a child to identify different objects. Over time, with exposure to various objects in repeated instances, the child learns to recognize and differentiate. That's pretty much how machine learning works, but with computers and data. Let's take a moment to understand how important data is in this equation. Data is the lifeblood of machine learning. It's like the textbook for the child, providing information and knowledge. The more quality data we feed into the machine learning model, the more accurate and efficient the predictions or decisions will be. Now, the realm of machine learning is vast and diverse, but its techniques can be broadly classified into three primary categories: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, we provide the algorithm with a labeled data set, which is like a solved textbook. The model learns from this data set and applies it to unseen data. Unsupervised learning, on the other hand, is like providing an unsolved textbook. The algorithm must find patterns and relationships in the data itself. Finally, reinforcement learning is like learning to ride a bike. The model learns by interacting with its environment, receiving rewards for correct actions and penalties for incorrect ones. Machine learning is a powerful tool, allowing us to unravel complex patterns and make sense of massive amounts of data. It's transforming industries, improving efficiency, and enabling us to tackle problems that seemed insurmountable. Machine learning, in essence, is the art of teaching computers to make decisions based on data. Quite intriguing, isn't it? Now that we've unraveled the mystery of machine learning, it's time to dive deeper into the realm of deep learning. Deep learning is a subfield of machine learning that pushes the boundaries of what is possible with artificial intelligence. It's like the younger, more ambitious sibling of machine learning, always eager to explore uncharted territories. But what makes deep learning so special? Deep learning employs neural networks with many layers. These are essentially algorithms designed to recognize patterns, almost like the way our minds work. Imagine your brain as a bustling city with neural networks as the intricate road systems connecting everything together. Just as a city's roadways allow for efficient travel and communication, neural networks allow for the efficient processing of data. They mimic the human brain's own network of neurons to process data and create patterns for decision-making. But what sets deep learning apart from its machine learning counterpart? One word: complexity. While machine learning algorithms can be relatively straightforward, deep learning algorithms are much more complex, often comprising of hundreds or even thousands of layers of artificial neurons. This complexity, however, comes with its own set of requirements. Deep learning requires significantly larger amounts of data compared to machine learning. It also calls for greater computational power, as these intricate networks of artificial neurons need to crunch through vast amounts of data. Despite these demands, the benefits of deep learning are immense. It allows us to tackle problems that are too complex for traditional machine learning approaches. From voice recognition in your smartphone to autonomous driving cars, deep learning is at the forefront of some of the most advanced technologies we have today. But perhaps the most fascinating aspect of deep learning is its potential to mimic human thinking. With each new layer we add to a neural network, we inch closer to creating machines that can understand, learn, and even think like we do. Deep learning, with its complex neural networks, takes us one step closer to creating machines that think like humans. Wondering where all this learning actually applies in the real world, the applications are as fascinating as the technology itself. Let's start with machine learning. One of its most prominent applications can be seen in e-commerce. You know those personalized product recommendations you see when you're shopping online? That's machine learning at work. Algorithms analyze your past purchases, browsing history, and even the behavior of similar customers to generate a list of items you might be interested in. This personalization doesn't just make shopping more convenient, it also helps businesses increase sales and customer engagement. But the influence of machine learning isn't confined to the digital realm. It's also being used to predict weather patterns, helping meteorologists give more accurate forecasts. It's transforming the healthcare industry, assisting in the diagnosis of diseases and predicting patient outcomes. It's even making our roads safer, with self-driving cars using machine learning algorithms to navigate traffic and avoid accidents. Now let's talk about deep learning, a subset of machine learning that's based on artificial neural networks. One of its most exciting applications is in the field of image and speech recognition. Ever used a voice assistant like Siri or Alexa? Or how about facial recognition to unlock your phone? These are all powered by deep learning. These technologies can understand and respond to human speech, recognize faces, and even interpret and describe images. Deep learning is also being used in healthcare for more complex tasks, like reading radiology images to detect cancer or other diseases. In the finance sector, it's being used to detect fraudulent transactions and prevent cybercrime. It's even being used in agriculture, helping farmers monitor crop health and optimize yield. From enhancing user experience to changing how we interact with technology, machine learning and deep learning are revolutionizing the world as we know it. Whether we realize it or not, these technologies are becoming an integral part of our everyday lives, helping us make better decisions, work more efficiently, and even stay healthy. And this is just the beginning. The potential applications of machine learning and deep learning are as vast and diverse as the data they learn from. Quite a journey through the world of machine learning and deep learning, wasn't it? We've explored the intriguing landscape of machine learning, diving into the algorithms and techniques that enable machines to learn from data. We've also delved into the realm of deep learning, understanding how neural networks mimic the human brain to process complex patterns. We saw the stark differences between machine learning and deep learning, how the former is a stepping stone to the latter, each with its own unique strengths. We also witnessed the real-world applications of these technologies, from self-driving cars to personalized recommendations, proving their immense potential. As we wrap up, let's ponder on the future. These technologies are not static. They continue to evolve and expand, promising to reshape our world in ways we can't even imagine yet. As we continue to unravel the mysteries of machine learning and deep learning, who knows what fascinating advancements await us in the future?